Yes, students, welcome to the class of hydraulic engineering. So, in this class, let us see the empirical formulae for the value of CHEZY'S constant. So, in the class, we'll be discuss about the empirical formulas which are associated with CHEZY'S constant, or how to calculate the value of CHEZY'S constant. Okay. So, first of all, let us start with, we have got the CHEZY'S constant from the value of velocity. We know that V is equal to C into under root mi. Okay, this is the value of where V is velocity of the flow, C is CHEZY'S constant, under root m. The value of m is wetted area by perimeter, and I is bed slope. So, from this the value of C comes as C is equal to V by under root mi. The value of C from this thing will be the value of C from this above equation will be V by under root mi. It will be the value of C is under root mi. So, if we write the dimensional formulae, dimensional formulae for V is the dimensional formula for V is L by T. Okay, the dimensional formula for V is m by T, and we know that under root m means A by P into I. The value of I comes with no units. Okay, the value of I comes with no units. So, the I is the dimensionless parameter. L by this T comes down, okay, into under root I also comes out. Later we will write it. Yes, students, welcome to the class of hydraulic engineering. So, in this class we will be discussing the topic called as empirical formulas for the value of CHEZY'S constant. Okay. So, CHEZY'S constant, when you hear this word, we have derived this CHEZY'S constant for while deriving the velocity, okay, velocity of flow in an open channel. So, from the equation of the velocity can be written as V is equal to C into under root mi. Okay, so where V is velocity, C is CHEZY'S constant, m, the value of m comes as area by wetted area by wetted perimeter, This is nothing but the value of m basically. Okay, and I is our bed slope of the bed. So, if we find the value of C from this above equation, it is as V by under root mi, So, if we write the dimensional formulas, on writing the dimensional formula, what is the dimensional formula of velocity? L by T it is. Okay, L by T divided by under root m. What is m? Area by perimeter. Area means L square by perimeter is L, okay, into bed slope. I is nothing but our dimensionless parameter. So, it comes as L by this T is over here, L by T L by T into root L into I basically, root L into I. So, from this equation, let I be the dimensionless parameter. If we remove I, this becomes root L by root L by T. So the value of C, the dimensional, if we write the value of C in the dimensional formulae, it comes at root L by T. So what does it means? That the value of CHEZY'S constant is not a dimensionless parameter. It is dependent upon root L by T values. It is dependent to root L by T values. So according to this, the following are the empirical formulas after the name of the inventors used to determine the value of C. So Bazin, a scientist Bazin, has given the formula known as Bazin's formula of C, which is equal to C is equal to 157. C by 1.81 plus K by under root M. Okay, so what is K over here? K is Bazin's constant. Okay, so from this, the value of K, this is the formula given by Bazin. Okay, scientist Bazin, to find the value of C, which is equal to C is equal to 157.6 by 1.81 plus K by under root M, where K is a Bazin constant and M is hydraulic mean depth or hydraulic radius. These values of K are given in a table. I will be showing these values of K of Bazin's constants is given. For example, for if the pipe or if the channel inside surface is smooth and cemented, so then the value of the K will be 0.11. If there is a earthen channel with rough surface, then the value will be around 3.17. So various values of K depending upon the channel, okay, inside surface of the channel, these values of K are given in this table. So if we substitute, depending upon the nature of the channel, if we substitute the values of K from this table into this formula, into this Bazin's formula, we will be getting the value of C, which is nothing but CHEZY'S constant. As here only two unknown parameters are there, the one is K and one is M. The K is the value of K, we are getting it from the table, depends upon the inside surface of the channel, where M is our hydraulic mean depth, which is equal to area by cross sectional area by wetted perimeter, where the value of M is cross sectional area by wetted perimeter. So by these two formulas, by substituting the value of K and value of M in this Bazin's equation, you can say, or in Bazin's formula, you can get the value of C, that is CHEZY'S constant, easily. So after Bazin, one more scientist has also given the empirical formula for C. That is nothing but Gangulet-Kutter formula. Gangulet-Kutter formula. According to Gangulet-Kutter formula, the value of C is, as you can see onto your screen, C is 23 plus 0.00155 by I. I is slope of the bed plus 1 by N. N is roughness coefficient. Okay, what is the N? N is roughness coefficient, or you can also say N as Kutter's constant also. Okay, you can say the value of N as Kutter constant or also roughness coefficient. I is bed of the slope. This divided by 1 plus 23 plus 0.00155 by I into N by under root M, where M is hydraulic mean depth, where M is nothing but hydraulic mean depth. So this here also the values, what it is constant over here, the values of N is constant, that is roughness coefficient, that is also given by the Gangulet-Kutter formula. A table for the values of N is given. For example, if your channel inside surface is very smooth surface of glass, plastic or brass, then the value of N that you have to use is the value of N which you have to use is 0.010. Okay, if you have an earthen channel with rough surface, if you have earthen channel with very rough surface, then the value which you have to use is 0.030. If you substitute this value of N, and M is hydraulic mean depth, whose formula is area by perimeter, whose formula is area by perimeter. The formula of M is area by perimeter. On substituting this value of N and value of M, you can get the value of C according to Gangliot-Kutter formula by substituting in this equation. The value of C which you are getting is nothing but CHEZY'S constant. The value which you are getting is CHEZY'S constant. After Basins and Gangliot-Kutter, one more scientist known as Mannings has also derived the formula for CHEZY'S constant. According to Manning, the formula for CHEZY'S constant is 1 by n m to the power 1 by 6. Okay, the value of Manning, the value of C according to Mannings is 1 by n m to the power 1 by 6, where m is hydraulic mean depth and n is Manning's constant and the n is Manning's constant. So, these three scientists, Basins, Gangliot-Kutter and Mannings, has given the empirical formulas to find the value of C, which is CHEZY'S constant, If you substitute those values in the equation V is equal to C under root mi, you will be getting the velocity of the flow in an open channel. You will be getting velocity of flow in open channel. Let us see the numerical example on this above three what we can say empirical relationships. So, the question is as follows: find the discharge through a rectangular channel of width 2 meter having a bed slope of 4 in 8000. Okay. The depth of the flow is 1.5 meter and take the value of n in Manning's formula as 0.012. So, here clearly he has given that we need to use the Manning's formula to find the value of C. Here in the question he has indicated that. So, the question once again I will repeat the question: find the discharge through a rectangular channel of width 2 meter having a bed slope of 4 in 8000. The depth of flow is 1.5 meter and take the value of n in Manning's formula as 0.012. So, first of all I will write the things which we need to find out, or the formulas which will be useful for calculating the desired result. Okay. So, discharge, what is the formula for discharge? Discharge is equal to A into AC under root mi, AC under root mi, and also to find the what is the value of m, hydraulic depth is equal to area by perimeter. And one more thing, the value of C, how to get the value of C? By Manning's formula. Manning's formula is C is equal to 1 by n m to the power 1 by 6, m to the power 1 by 6. So, these three equations we will be using. Okay. So, write the given details, what all things are given in the problem. So, width is given, width is nothing but 2 meter, width of the rectangular channel is 2 meter, having a bed slope I, the value of I, bed slope 4 by 8000 it is given, 4 by 8000. If we substitute if we cancel this, 4 ones are 4 2000s are. So, it becomes 1 by 2000 or 1 in 2000, the value of bed slope. The depth of the flow D is given as 1.5 meter. Okay, the depth of the flow is given as 1.5 meters and the Manning's the value of n, okay, is 0.012. 0.012 is the value of n in Manning's formula, So, first of all let us find the value of m. Okay, hydraulic mean depth m is equal to area by cross sectional area by perimeter, or wetted area by wetted perimeter. So, as this is the rectangular channel, the area of channel is width into depth of the flow, that is 2 into 1.5 meter divided by perimeter for rectangular channel. Perimeter for rectangular channel is b plus 2d, b plus 2d. So what is the value of b? 2 it is given, 2 plus 2 into what is d? 1.5, 2 into 1.5. So from this the value of m is equal to 2 into 1.5 is 3 by 5. So here the value of m comes as 0.6. 3 divided by 5 is 0.6. 3 divided by 5 is 0.6. Now substitute this value of m in CHEZY'S formula, Manning's formula. According to Manning's formula, C is equal to 1 by n m to the power 1 by 6. Okay, so C is equal to 1 by n. What is the value of n? 0.012 into value of m is 0.6 whole to the power of 1 by 6, whole to the power 1 by 6. So from this, on solving this, we will get the value of C around 76.54. On solving this above equation, you will get the value of C as 76.54. Now to calculate the value of discharge, now we will calculate the discharge. Discharge is Q is equal to AC under root mi, AC under root mi. What is the area? 2 into 1.5, 3 meter square is the area. The value of C is 76.14. The value of C is 76.54. 76.54 into the value of m is 0.6 into I is 1 by 2000. 1 by 2000. On solving this equation, 3 into 76.54 into under root 0.6 into 1 by 1000, the value comes as 3.97 meter cube per second. So the discharge through open channel or rectangular channel, there is a 3.97 meter cube per second discharge through a rectangular channel of width 2 meter, having a bed slope of 4 in 8000 with a depth of flow of 1.5 meter, and the value of n in Manning's formula as 0.012. So our final answer is 3.97 meter cube per second. The next question is as follows. Find the diameter of a circular sewer pipe which is laid at a slope of 1 in 8000 and carries a discharge of 800 liters per second when flowing half full. Take the value of Manning's n is equal to 0.020. So remember, over here there is one special condition given over here, that is nothing but the sewer is flowing the half full. It is not flowing completely, it is flowing half full. Okay, when it is flowing half full, just remember this condition. It does not as you can see into the figure, the sewer or the water which is flowing through a circular sewer does not full to its capacity, it is flowing the half full. So find the diameter of a circular sewer pipe which is laid at a slope of 1 in 8000 and carries a discharge of 800 liters per second when flowing half full. Take the value of Manning's n as 0.020. So let us write the details. What we need to find out? Diameter. We need to find out the diameter. Okay, we need to find out the diameter of the sewer. Okay, so what are the given things? Bed slope is given, the value of I is given, the value of I is 1 by 8000, 1 by 8000, and discharge Q is given, Q is equal to 800 liter per second. If we convert it into meter cube per second, divide it with 1000, it becomes 0.8 meter cube per second, 0.8 meter cube per second. To convert liter per second into meter cube per second, we need to divide the value by 1000. We need to divide the value by 1000, and also the value of n is given. The value of n is given as 0.020. The value of n is given as 0.020. So first of all, let D be the diameter. Let capital D be the diameter. Of circular sieve. So if you look at the figure, so what is the depth of the flow? Depth of the flow is diameter by 2. If we look at the diagram, depth of the flow, if we talk about depth of flow, it is nothing but capital small d, depth of the flow small d is equal to capital D by 2, and when we talk about so what is the area of the flow? When we calculate the area of the flow, the area of flow is it is not total circular, but it is semicircular. So the area of flow is pi d square by, generally what is the area of total circle? Pi d square by 4. So in this case, pi d square, the area of the flow is nothing but area of semicircle, that is pi d square by 4 whole divided by 2. So it is pi d square, here the d becomes capital D, pi d square by 8. Okay, pi d square by 8. And now wetted perimeter. What is wetted perimeter? It is the circumference of semicircle. Which is equal to pi d by 2. What is the circumference of circle? Pi d. Okay, as this is a semicircle, we need to divide it by, as the flow area forms a semicircle, we need to divide it with 2. So wetted perimeter is pi d by 2. So if we calculate the hydraulic mean depth, so if we calculate the hydraulic mean depth, which is equal to m, hydraulic mean depth, m is equal to area by perimeter. So m is equal to, what is the area? Pi d square by 8 is the area, by what is the perimeter? Pi d by 2 is the perimeter. So the hydraulic mean depth, the value of m becomes d by 4. There is our hydraulic mean depth. After calculating the hydraulic mean depth, let us find the value of C. We know that value of C is equal to, according to Manning's, 1 by n m to the power 1 by 6. According to the Manning's formula, the CHEZY'S constant C is equal to 1 by n m to the power 1 by 6. So from here the value of C, CHEZY'S constant, is 1 by, value of n is 0.02. Okay, 0.020 into the value of m is, if we can substitute it now also, we will substitute the value of m later. Okay, m to the power of 1 by 6. This is the value of our CHEZY'S constant. C is equal to 1 by n m to the power 1 by 6. We will substitute this value of m, that is d by 4, later. Okay. So what we need to calculate? We need to calculate discharge. So what is the formula of discharge? The formula of discharge is Q is equal to, AC under root mi. So value of Q is already given, that is 0.8 meter cube per second. Okay, the value of Q is already given, 0.8 meter cube per second, is equal to area. What is the area of flow? Area of flow is pi d square by 8. Look at, Here we have look at this calculation. We have derived the area of flow as pi d square by 8. Okay, pi d square by 8 into what is the value of C? 1 by 0.020 into m to the power 1 by 6, m to the power 1 by 6 into m to the power 1 by 2. I am breaking it, okay, into m to the power of 1 by 2 into under root. What is the value of I? 1 by 8000 is the value of I. 1 by 8000 is the value of I, which is nothing but bed slope. If we rewrite this equation, 0.8 is equal to pi d square by 8 into 1 by 0.020 into, we know that a raised to m into a raised to n is a raised to m plus n, a raised to m plus n. So this becomes m to the power 2 by 3 into under root 1 by 8000 into 1 by under root 1 by 8000. Now substitute the value of m as d by 4. Now substitute the value of m as d by 4. So it becomes 0.8 is equal to pi d square by 8 into 1 by 0.020 into d by 4 whole to the power of 2 by 3 into 1 by 8000, 1 by 8000. Now if we look at this equation, look at this equation A. In this equation A, just only D is unknown quantity, just D is the unknown quantity, rest all values we have substituted, rest all values we have substituted. So from this, on solving this equation A, on solving this equation A, we will be getting the value of D. On solving this above equation A, we will get the value of D. So D to the power 8 by 3 is equal to, it comes around 9.18. It comes around 9.1848. Okay, 48. So from here the D is nothing but so from here the value of D will be 9.1848 whole to the power 3 by 8. 3 by 8. If you send 8 by 3 to other side, it becomes 3 by 8. So it will be, if we solve this, the value of D is equal to, we will get the value of D as 2.296 meters. We will get the value of D as 2.296 meter. So that's what we were asked to find out in this problem. Find the diameter of a circular sewer pipe which is laid at a slope of 1 in 8000 and carries a discharge of 800 liters per second when flowing half full. Take the value of Manning's n is equal to 0.020. So we have found it out, the value of D as 2.296 meter. We have found out the value of D as 2.296 meter.